The MagRail Booster by Nevimo is a groundbreaking retrofit solution that transforms standard freight wagons into self-propelled, locomotive-free units. Using advanced linear motor technology integrated directly into existing rail tracks, each wagon gains the ability to accelerate, brake, and operate independently either as part of a train or on its own. The system installs a linear motor stator along the track, while wagons are fitted with smart control electronics and passive onboard components to communicate seamlessly with the rail system. An intelligent command and control network ensures precise synchronization, safety, and energy-efficient performance, even on non-electrified lines. The MagRail Booster dramatically improves rail efficiency and flexibility, allowing higher train frequencies and reducing reliance on traditional locomotives. Ideal for industrial hubs, terminals, steep routes, and last-mile transport, it brings new agility to freight logistics. Through pilot projects in Germany and Poland, Nevimo is demonstrating how this system can revolutionize rail transport, modernizing existing infrastructure without costly new rolling stock or major construction. The ESA Future Space Transport Ecosystem is an ambitious initiative by the European Space Agency, ESA, under its Future Launches Preparatory Program, designed to establish a modular, reusable, and interoperable space logistics network. Moving beyond traditional one-time rocket launches, ESA envisions an interconnected system of orbital hubs, autonomous spacecraft, and service vehicles capable of docking, refueling, repairing, and maintaining satellites directly in orbit. Operating on a hub-and-spoke model, the system will use orbital hubs as refueling depots, maintenance bases, and assembly stations, while transfer vehicles handle payload transport between orbits or even to lunar destinations. Development is organized across specialized programs: BEST for reusable boosters, Thrust for propulsion technologies, FIRST for breakthrough innovation, and InSpock for in-space demonstrations. With industry collaboration and standardized interfaces ensuring cross-compatibility, ESA's future space transport ecosystem marks a bold step toward sustainable, autonomous, and service-oriented space operations that redefine how humanity builds and maintains its presence in orbit and beyond. The TAE Norm Fusion machine by TAE Technologies represents a major leap toward practical, clean fusion energy. Using a beam-driven field-reversed configuration, FRC, it's the first fusion system to create, heat, and stabilize plasma entirely through neutral beam injection, eliminating the need for complex end structures found in earlier designs. Compact and efficient, Norm is a refined evolution of TAE's previous prototype, Norman, featuring fewer components and enhanced operational stability. Built for steady-state performance, Norm achieves stable, fusion-relevant plasma at critical temperature thresholds while integrating advanced power systems, active beam control, and real-time stabilization. Its success lays the foundation for TAE's next-generation Copernicus reactor, which will push toward commercial fusion. By utilizing hydrogen-boron fuel, Norm operates with virtually no radioactive waste, showcasing a promising and sustainable pathway to clean, continuous fusion power for the future. Microfluidic cooling represents a breakthrough in thermal management, bringing liquid cooling directly inside semiconductor chips. By embedding microscopic fluid channels within or adjacent to the silicon, coolant flows exactly where heat is generated, eliminating the need for bulky heat sinks or external plates. This innovation allows heat to dissipate several times more efficiently than conventional cooling systems. In a collaboration between Microsoft and Corintis, tests have shown that microfluidic cooling can remove heat up to 3 times faster and reduce peak chip temperatures by as much as 65%. Ideal for 3D, stacked and high-density circuits, this approach balances thermal loads across layers while lowering overall energy use. Researchers are continuously optimizing channel geometries, flow paths, and advanced fluids, including nanofluids and biomimetic designs modeled after natural vascular systems. By integrating cooling at the silicon level, microfluidic technology is redefining the limits of chip performance, paving the way for faster, more efficient, and more sustainable computing hardware. Cognify Facility is a visionary rehabilitation concept developed by Hashim Al-Ghalai, redefining justice through neuroscience and artificial intelligence rather than imprisonment. Instead of confining offenders, Cognify proposes an AI-driven cognitive rehabilitation system that implants artificial memories designed to replicate the emotional consequences of their crimes. Within minutes, offenders experience guilt, remorse, and empathy as if they had lived through the victim's suffering, transforming punishment into deep psychological reform. The process begins with an advanced neural mapping scan to identify areas tied to memory and emotion, followed by AI-generated sensory experiences delivered through neural implants or immersive headsets. These clean, futuristic facilities feature no bars or cells, only precision technology aimed at reshaping the mind rather than restricting the body. While the concept offers a bold alternative to incarceration, it raises profound ethical concerns surrounding consent, identity, and the manipulation of human consciousness. Though still speculative, Cognify challenges us to rethink the nature of justice and the future of human rehabilitation. The Phantom 3500 by Auto Aviation is a revolutionary super mid-size business jet that redefines private air travel through unmatched aerodynamic design, sustainability, and technological sophistication. Developed from a completely new blueprint, it features advanced laminar flow aerodynamics that reduce drag by nearly 35%, dramatically enhancing efficiency and performance. Its seamless, windowless fuselage replaces traditional windows with high-definition, supernatural vision displays, projecting real-time panoramic views while preserving the aircraft's sleek exterior profile. Crafted from lightweight carbon fiber composites, the Phantom 3500 delivers exceptional fuel efficiency and a range exceeding 3,000 nautical miles, cruising effortlessly at 51,000 feet. The luxuriously quiet cabin, standing 6.5 feet tall, accommodates up to 9 passengers in refined comfort. Powered by sustainable aviation fuel, it cuts carbon emissions by up to 60%, embodying the future of eco-conscious aviation. With its fusion of digital luxury, aerodynamic mastery, and environmental responsibility, the Phantom 3500 represents auto aviation's bold vision of next-generation flight. Nissan ProPILOT is a cutting-edge driver assistance system created to make driving safer, smoother, and more relaxing, especially on highways. As part of Nissan Intelligent Mobility, it uses a network of radar, cameras, and sensors to automatically manage steering, acceleration, and braking, keeping the car centered in its lane while maintaining a safe distance from other vehicles. It performs exceptionally well in stop-and-go traffic, easing driver fatigue during daily commutes. One of its most impressive features, ProPILOT Park, allows for fully automated parking in both parallel and perpendicular spaces with minimal driver input. With the NA6 link enhancement, the system becomes even smarter, using navigation data to anticipate curves, junctions, and speed changes for more natural control. Future upgrades are expected to bring AI integration, LiDAR, and enhanced perception systems, enabling operation in more complex urban environments. While drivers must remain attentive, Nissan ProPILOT represents a major leap toward the future of semi-autonomous driving and intelligent mobility. Deep Robotics X30 is a powerful quadruped robot built to excel in industrial and field operations where human access is difficult or hazardous. Designed for resilience, it operates reliably in extreme conditions from -20°C to 55°C, with an IP67 rating for dust and water resistance. X30 can climb open riser stairs, tackle 45° slopes, and step over 20 cm obstacles, making it ideal for navigating tunnels, factories, and construction sites with ease. Equipped with a fusion perception system that integrates visible light and thermal imaging, the X30 uses advanced algorithms for mapping, obstacle avoidance, and autonomous navigation even in total darkness. Can reach speeds up to 4 meters per second, run for 4 hours per charge, and features a swappable battery for continuous missions. Already deployed in Singapore under the name Spock, the X30 autonomously inspects underground power tunnels for cracks and leaks, showcasing the next Operation of robotic inspection, maintenance, and industrial safety solutions. Vertechs AXON is a cutting-edge big data analytics platform built to revolutionize well engineering in the oil and gas industry. By leveraging artificial intelligence and real-time analytics, AXON unifies structured and unstructured data from drilling logs and field reports to live sensor readings into one intelligent ecosystem. This enables engineers to monitor, predict, and optimize operations in real time, spotting anomalies and inefficiencies before they become costly problems. Designed for both on-premises and private deployments, AXON ensures robust data security while offering customizable dashboards for clear, actionable insights tailored to each project. Its predictive intelligence enhances wellbore integrity, minimizes downtime, and fine-tunes operational parameters to boost safety and efficiency. By turning massive, complex data sets into precise and proactive intelligence, Vertechs AXON empowers energy companies to operate smarter, faster, and more sustainably. CA-1 Europa by Helsing, developed in partnership with Grob Aircraft, is a next-generation autonomous combat jet redefining European air defense through AI-driven autonomy and modular innovation. Designed as a mid-size uncrewed aerial vehicle, it's powered by Helsing's Centaur AI pilot system, enabling fully independent flight, tactical assessment, and combat engagement without human control. The Europa's adaptable airframe features internal payload bays that can be configured for sensors, weapons, or electronic warfare tools, ensuring mission versatility. Its stealth-optimized design, featuring cranked wings, canted tails, and angular surfaces, minimizes radar detection while allowing operations from dispersed or rugged bases. Whether operating solo or as part of a coordinated swarm alongside manned aircraft, the CA-1 Europa embodies the future of sovereign European defense, blending AI intelligence, modular design, and autonomous precision into one formidable combat platform. Vertiv CoolPhase Flex is a cutting-edge hybrid cooling solution designed for AI, HPC, and hyperscale data centers, integrating both air and liquid cooling in a single outdoor packaged unit. Building on Vertiv's proven Libera DSSE platform, it lets operators start with conventional air cooling and seamlessly upgrade to liquid cooling in just a few hours without extra components or downtime. Delivering up to 400 kWh of cooling capacity, CoolPhase Flex features variable speed compressors for adaptive efficiency and pumped refrigerant economization, enabling partial or full free cooling whenever ambient conditions permit. Its self-contained outdoor design saves indoor space and supports flexible perimeter or rooftop installation. Fully modular and upgradable, Vertiv CoolPhase Flex empowers data centers to handle increasing thermal loads efficiently, optimizing energy use while preparing for the next generation of AI-driven workloads. Skyfall is an ambitious Mars exploration concept developed by Aero Environment in collaboration with NASA's Jet Propulsion Laboratory. It envisions a fleet of 6 autonomous helicopters tasked with scouting, mapping, and locating critical surface resources such as water and ice, providing advanced reconnaissance ahead of future human missions. A standout feature of the mission is the Skyfall maneuver, where the helicopters detach from their descent capsule mid-entry and land independently on the Martian surface, eliminating the need for a separate lander and simplifying mission logistics. Each aircraft is equipped with high-resolution cameras and radar systems to generate 3D terrain models and detect subsurface materials. Building on the success of Ingenuity, Skyfall expands the concept to a coordinated aerial fleet capable of autonomous and collaborative operations. If executed, this approach could transform Mars exploration by delivering agile, distributed intelligence across the planet like never before. Willow Quantum Chip. Google Quantum AI's latest breakthrough, the Willow chip, is a 105 transmon-qubit superconducting processor developed at their Santa Barbara facility, marking a major leap in error-corrected quantum computing. Unlike previous generations, Willow achieves below-threshold scaling, meaning that adding more qubits actually reduces error rates exponentially, overcoming one of quantum computing's most persistent challenges. The chip has demonstrated random circuit sampling in under 5 minutes, a task estimated to take classical supercomputers over 10 septillion years, showcasing a striking new level of quantum advantage. Willow also introduces key hardware improvements, including longer coherence times, enhanced interqubit connectivity, and refined integration of quantum gates, readouts, and resets for stable, reliable operation. While not yet capable of breaking classical encryption like RSA, Willow represents a pivotal step toward fault-tolerant, scalable quantum systems, bridging the gap between experimental physics and practical quantum computing, poised to transform the computational landscape. Proxima Fusion, a spin-off from the Max Planck Institute for Plasma Physics, is developing the Stellaris Fusion Power Plant, a next-generation fusion concept based on a quasi-isodynamic stellarator design. Unlike tokamaks, stellarators enable more stable, continuous plasma operation, making them a strong contender for practical fusion energy. Stellaris leverages high-temperature superconducting magnets to generate stronger magnetic fields in a more compact and efficient form. Peer-reviewed studies confirm that the design balances plasma confinement, structural integrity, thermal management, and neutron handling. The plant is expected to achieve higher power output per unit volume, enabling smaller yet highly powerful fusion facilities. Proxima aims to test its magnet technology with a stellarator model coil by 2027, followed by the alpha demonstration device around 2031, targeting net-positive fusion. Full-scale commercial Stellaris plants could arrive in the 2030s, offering clean, reliable, and continuous energy for the grid. The CATL Freevoy dual-power battery ushers in a new era for electric and hybrid vehicles with its innovative dual-zone architecture. Each of the two independent energy sections operates with its own voltage, cooling, and safety systems, providing redundancy, optimized power management, and dynamic mode switching, allowing smooth cruising or bursts of high power on demand. Its standout feature is a self-forming node, which creates a dense internal structure during early charging cycles, boosting energy density with up to 60% higher volumetric and 50% higher gravimetric performance compared to previous generations. The flexible design supports hybrid chemistry pairings, such as sodium-ion with LFP for cold weather performance or NCM-LFP for long-range and high-power applications. Capable of 12C fast charging and stable operation even at -40 degrees Celsius, the Freevoy battery combines endurance, adaptability, and reliability. Already planned for integration in vehicles from Leapmotor, JAC, and Chery, it is redefining expectations for next-generation EV power systems.